All right, so we are live. I'm just gonna move this down here. Just get you guys set a little bit closer. All right. Good morning, everyone. I'm Jillian from Sharks for Kids, and we're really excited to be back at the Bimini Sharklab to share a little bit of shark science with you today. We have a few classrooms joining us live. We're really excited, and hopefully a few people watching along. And we're at the Bimini Sharklab, which is on the South Island of Bimini in the Bahamas. It's about 50 miles from Florida, so not too far from the United States. And the lab was started in 1990 by Doc Gruber as a base for his lemon shark research. And since then, it's really become world-renowned. If you guys have watched shows on Shark Week or Discovery Channel, Animal Planet, you've probably seen this place, and you've probably seen some of the research that's being done. So today, I have an amazing team here with me, and I'm going to let them introduce themselves, and then we're going to let you guys meet our very special guest. So,
hi, good morning or good afternoon. My name is Angela. I'm the manager of the Sharklab, and my role here is to take care of all the volunteers, oversee all the research, and just make sure that everything runs really well. So welcome to the Sharklab.
Hi guys, my name is Jessie. I am the outreach coordinator at the lab. I'm from London, England, and my job here is mainly education. So I go to schools, I talk to people about the work we do, and basically inform the public about all the exciting research we've got going on at the lab.
Hi, my name's Tabitha. I'm from Australia. I'm an intern here at the Sharklab. I've been here since August, and I'll be leaving in December.
Awesome. All right, so now we're going to introduce some of the classrooms that are joining us. So if you hear your classroom's name, please unmute your microphone, give a big shout out, hi to everyone. So first up, we have Miss Gonzalez's first grade class. So if you guys want to wave and say hi.
I'm gonna you when she said.
Hi. You guys say hi. All right. So then we have Miss Shilly's third grade class. Do you guys want to say hi? All right. We have some students excited to learn about sharks. All right. Then we have Miss Baldino's kindergarten class. If Miss Baldino's kindergarten class wants to wave and say hi. Well, I can see them. I'm not sure if they're hearing us okay. Hopefully they are. And then last but not least, we have Miss Judy's grade class.
Hi.
All right. Well, good morning to everyone again, to our classrooms. Thank you so much for joining us. We're really excited for you to be here. And I'm just going to go ahead. Yep, and I think everyone's got their mics muted. Perfect. All right, so what we're going to do today is we're going to talk a little bit what shark science actually is. You may have heard people talk about studying sharks, tagging sharks. So we're going to talk a little bit about what that actually means. And as we're doing that, we're going to show you what it looks like. So we have a very special guest. So here in Bimini, one of the things that the lab does is they have a pen outside. And you can think of it, you've seen cows or pigs or horses in a pasture with a fence. It's one, but it's in the ocean. And there are not cows or horses in there, there's sharks. So the lab will go out and catch some juvenile sharks. They'll get in the pen, they'll stand for about 30 days, and then they're released in the exact spot they were caught. And while they're in there, interns get to learn about them, how to safely handle them for doing the tagging. The general public can come visit. If you guys are ever in Bimini, you can come take a tour. You can see the lab, see what goes on here, meet the team, and also to do research. Right? So these animals are a really important part of learning more about sharks in general, or the specific species. So this morning, we have a very special guest with us. So I'm going to go. All right. She's a little camera shy. You're all right. Oh. All right, I don't want her, she's touching the computer. All right, so we have a special guest. All right. So you guys might think doesn't look like a shark, but believe it or not, that's actually a nurse shark. And this is one of the species that's kept here. They're one of the species found in Bimini in all sizes, right, from birth to adult, which is really incredible because it means we can learn a lot about them from their entire life stages, right, from birth to being an adult, how they reproduce, where they spend their time, what they eat. So it's really amazing to have access to all the different life stages. So it's kind of like babies, teenagers, adults, having access to them to be able to learn because they do change over time. So what we're going to show you here today is we're going to talk a little bit about some of the characteristics of this shark. Because you probably noticed and went, wait a minute, that doesn't look like a shark. But this is a shark, and so Angie's going to talk a little bit about the anatomy, some of the key features. Then we're going to show you guys a little of the equipment that is actually used when we're studying sharks, and then finish up with a workup. So how do we collect data? What do we want to know about this animal? How do we gather that information? Right, so we're going to start out with a little bit of anatomy.
Okay, so I'm just going to get in here. She's a female. So I'm just going to grab her very gently. One thing about sharks is that they are not like normal fish. They are made of cartilage. So I'm just going to show you how flexible she is. She can actually bend so far that she can bite her own tail. So the cartilage is similar to what we have in our nose and our ears. So if you bend your nose and your ears and wiggle it around, can you feel how bendy it is? That's how bendy a shark is. So that makes them, it makes it very easy for them to go into crevices and holes and things to get their food. It also makes them very light in the water so they can stay in the middle of the water column. Okay, so I'm going to start telling you about the senses. So sharks have pretty much the same senses as what we do, but they have some extra special ones too. So as you can see, this little girl has eyes. She has very small eyes, and this is because they live pretty much most of their lives under rocks. So if they had big eyes, then it would they would probably get scraped by the rocks. So they have really, really small eyes, so that they so they're more protected. So this little girl has a nose, or we call them nares. Can you see her nares just there? And they basically use their noses for smelling. They have really, really, really good smell. Most of their brain is dedicated to smell, but they don't actually use their nose for breathing. They use something called gills. So this little girl, most sharks have 5 to 7 gills. This little girl has 5 gills, but you can only see 4 because one of them is fused, is stuck to the last one here. I don't know if you can see, but can you see also the gills? And you can see how she's breathing. The gills are moving because she's breathing. What else? She's very feisty. Okay, let's talk about her teeth. You can't really see her teeth, but a lot of sharks, I'm sure you've seen a great white, and they have the really, really pointy teeth. Well, most sharks have different shaped teeth depending on what they eat, and great whites eat very fatty seals and marine mammals, so they really need the pointy teeth, whereas this little girl, she eats on the bottom of the ocean, and she likes to eat things like shellfish and like lobster and conch. And she needs to have really flat teeth that are able to cut through shells. So her teeth is different to other species of sharks. What else? Skin. So these sharks have something called dermal denticles. And these dermal denticles are made from the same material as what our teeth are made from. I'm just going to let her go for a minute. And they are plates of teeth that sit on top of each other, and they go all the way to the tail. And basically what these do is they create little ridges, and so it makes it easier for the water to pass over them, so they can swim through the water a lot quicker. If they didn't have these, the water would be really like, it would create a lot of energy and would actually stick to the skin of the shark. So it would make it more difficult for them to swim. So this is why you can see sharks swimming really fast through the water. Now this little girl doesn't really move much. So her dermal denticles are a lot bigger and with less little rivets than normal sharks like a great white, because she doesn't need to move much. And so basically this little girl spends most of her time on rocks, as I said, and you can see by her body shape. She has several fins. Can you hold it? Thanks. You got it. So I'm just going to show you, explain the different fins. So she has pectoral fins, dorsal fins, an anal fin, pelvic fin, and a caudal lobe. This is the tail. Okay. I'm just going to let her breathe for a second. As you can see, she's quite flat in comparison to other shark species, which are more torpedo shaped. And this is because she lives under rocks most of the time. So she has flat pectoral fins. Her dorsal fins are set very far back on her body. And another thing you can see here is she only has an upper part of the tail. As she had a lower part of the tail, it would stick in the sand and she wouldn't be able to move. And the reason why she doesn't need that lower part of the tail is because she doesn't move very far or very fast. Now the big sharks like great whites, the ones that need to move very quickly, have a lower lobe because it gives it that extra propulsion. So it makes them swim really fast. And she doesn't actually have that because she doesn't need it because of where she lives. So I'm going to show you how you tell if it's a boy or a girl. So under here, the pelvic fins. If it's a boy, they have like, whoop, sorry, sorry, pointy like appendages. Oh gosh, and then that's how you can tell it's a boy. And this little girl doesn't have any; she just has normal pelvic fins. So that's how you can tell it's a boy or a girl. Scared me. What else? Yeah? You sure? Okay. Okay, so that's it from me. I'm going to pass you over to the girls, and they're going to show you how to do a shark workup.
I'll do the tags. Okay. Yeah. All right. So, oh, sorry. That's okay. So, so the next thing we're going to do is actually talk a little bit about some of the equipment. So, we're going to show you the workup that when sharks are captured, all over the world, scientists collect specific data, and we're going to see that in the workup. But before you release the animal, you want to give it sort of a name tag, right? Because we can't remember all these sharks. If you're catching hundreds of sharks, thousands of sharks, you know, they look pretty similar. You can't remember all of them. So it's really a way for us to have an ID tag for each animal. Now, there's lots of different types of tags, and the one that we're going to use really depends on the study, the questions that scientists are asking. What do we want to know about this specific shark? And how is this tag a tool to help us do that? Right? So the first tag I'm going to show you is really, really small. Some of you might have a pet at home that has one of these. It's called a pit tag or a microchip. All right, so if you can see, believe it or not, that tiny little kind of grain or brace size tag in my hand, that's a shark tag. Now, if your cat or dog has a microchip, it has this in between its shoulder blades. And think of when you go to the store and you get an item and it goes over the register, there's a black and white code on the back of it called a barcode. This is a barcode for a shark. There's a special scanner. Guys, can you hand me the scanner? Thank you. There's a special scanner, so when a shark is caught, you'll actually scan it with this, all right? And there'll be a number that will come up, right? So if you guys can see, this is the number. So it's really long. It's not like a name. It's pretty long, so you got to make sure you write that down because you definitely won't remember that one. This is the exact same thing the Humane Society or a vet would use for or dog. So if your cat or dog gets lost, they scan it. If it's got a chip, it's linked to your address, your phone number. We're not going to try and find lost sharks. There's no address or phone number attached. It's simply just a number so that we can identify that shark if we catch it again, or another scientist. Say this nurse shark is released and somebody in Florida catches it. Cool, we can learn that our shark swam to Florida, and maybe we can see how long it took or how much time they're spending there. Really basic tag. Another very simple tag that we can do has a couple different names. It's a Casey tag or a dart tag. Sometimes the shape is also a spaghetti tag. You can see kind of long and thin, attaches in the shark, and instead of having a number inside on a code, it's got a number on the tag itself. All right, so that goes on the shark, like kind of like an ear piercing, just below the dorsal fin. And with this and the pit tag, we have to catch the shark again or see it again, right, to have access to learn more. We catch it again, maybe it's in a new spot, like I mentioned, or we can remeasure it. But we really have to have access either to see the animal or catch it again to learn from that tag. But they're pretty inexpensive, so it's very easy to put a lot of those out there to increase the likelihood of possibly catching that shark again. Now, as technology is getting more advanced, think about what your iPhone can do now, all right? It can give you a GPS location. It can take photos, videos, all these cool things. Technology is changing for science as well and changing for research. So as that's happening, so isn't our ability to study sharks using some of this new technology. Now, these are a couple versions of tags that are called acoustic tags, all right? So might not look like a whole lot, and one can go inside a shark. It's smaller, so this would go in a smaller shark, or it can also be attached in an external mechanism. And it's acoustic because they make a noise. So you can think of these as each having their own ringtone, right? Each one has a unique ringtone. You wouldn't hear it. The shark doesn't hear it, so it's not driving them crazy, like it's just constantly a song playing. But we have special receivers, ones that we can put in the water and actually listen, like a big underwater hydrophone. It's a big ear. Or all along the Bahamas, up the eastern seaboard of the United States, usually when researchers are using these, they're receivers, and they sit on the bottom and look like this. Believe it or not, there's a computer in here that can listen specifically for those tags. That's its only job. It listens for those tags. And when an animal swims, it depends on the type of tag, but anywhere from about 300 to 1,500 feet within the range of that receiver, it records the tag number, the time of day, the water temperature, and the date. So what this tells us is how often the shark is hanging out in that area, right? Do they show up for lunchtime every day at the same time? And are they hanging out with the same sharks? Right? It's part of the reason that the lab actually discovered juvenile lemon sharks have best friends, right? Not just friends, but best buddies. They did it through observation, watching them, but also seeing the same sharks in the same area consistently. So they were hanging out with their buddies, right? Pretty amazing, because a lot of people think sharks are sort of these mindless eating machines. They're not social. Some of them are extremely social and actually have best buddies, just like we do, which is really cool. All right, the last tag I'm going to show you is probably the kind of the fanciest. It's been painted over, but if you could see inside of it, there's a mini computer, there are batteries, and this is pretty much like strapping an iPhone to a shark, right? Obviously, we can't strap an iPhone to a shark, wouldn't last. But just like an iPhone can tell you where you are, you can get directions, this can tell us where the shark is. And you see this antenna? So when the shark comes in, this goes on the dorsal fin. The shark's dorsal fin sticks up out of the water, and this antenna, bing, up to a satellite. And believe it or not, we actually get an email from our shark, right? It's pretty amazing. So the shark crafts us a nice little note saying we're there. No, just kidding. The tag actually just gives us the GPS location, and we can run it through a program and kind of play a big game of connect the dots to see where the shark is swimming. And then we can look at, okay, why are they swimming there? Why are they spending time in that area? So it helps us figure out a little bit about the shark's life, why they're going to certain areas. Is it to feed? Is it to mate? Is it to give birth? Things that drive animal migrations. Why do animals move? These are the kind of the main reasons. So it helps us get a better idea of what it's like to be this animal and why they do the things they do. Really important, because if we want to protect sharks, you guys may have heard that sharks are in trouble. About 100 million sharks are killed every year, which is a really big number. And so if we don't learn about them, it's going to be really difficult to protect them. And what you're going to see next is the data collection. And this is really important, having this information with these tags to get better protection put in place. Here in the Bahamas, it's a shark sanctuary, so it's actually illegal to catch and kill sharks. And a big part of that came from data and science that was done right here in Bimini about these specific animals, learning about the habitats they use, the areas they go that are really important. And that's how scientists and organizations were able to go to the government and ask them to protect sharks, because there was scientific data to support the reasons that they needed to be protected. So these tags, the workup you're going to see, really, really important for being able to protect sharks so that more species don't become endangered or even become extinct. All right, cool. So we're going to get to see a little bit of what a scientific workup looks like.
Hi guys, so we're going to do a scientific workup for you. So this, as Jill said and as previously mentioned, this is how we collect all our data from these animals. So it's a collection of samples and measurements that are extremely important for understanding these animals. Now you can think of it like going to the doctor for a checkup. When you go to the doctor, they take your height, they might give you a shot, kind of like that. So if you think of it like that, that's exactly what we're doing for these sharks, from the small to the really big ones. So we're going to get started. Obviously, everything we collect, all the data we collect, gets written down in a book like this. So we can look back on it if we recapture a shark, and we can compare some of the measurements. So what we've got here is we've got a trough with a measuring tape inside. Can you see that? So what we're going to do is we're going to place this over the trough here. We're going to pop some water in it so our shark can see, can breathe. And we're going to pop this shark at the start of this measuring trough. I'm just going to see if I can point the screen down. Perfect. And then I've got Tabitha here with me now. She's going to pick up the shark and she's going to pop it in the measuring trough.
You guys can see this.
So she's going to swim it up to the top. And so it's sitting, so its snout, it's sitting right here. And what we're going to do is we're going to take some length measurements for this guy. Now, this first measurement we take is called the pre-caudal length. So it's just the notch before the caudal tail here. So if I pop my little tweezers down, you can see that it says 40.2 centimeters for the PCL. You see that? Now, some sharks have a lower lobe here, so then we take a fork length. But this little nurse shark doesn't have that, so we take something called a total length. So right at the end of the shark, we stretch the tail out and we put our little measuring thing down here, and we can see it's 57.6 centimeters. So it's a small little guy. So that is the measurements we take for the length that's from the snout to the tail. The next thing we take is we take a girth measurement. So I'm just going to grab another measuring tape. This goes below the shark here. So Tabitha's just going to lift this little girl up. It just sits underneath the armpit. So it's like taking a waist measurement when you go to get new trousers or something like that. Just going to lift it up again to turn it the right way. We're going to put this underneath the shark. We're going to shuffle it all the way up to the armpit, and we're going to take a measurement here. So quickly, take it away nice and quick, and the measurement for this shark is 21.5 centimeters in girth. So still quite small, so got some growing to do and got some food to eat to get nice and big. The next thing we do is we take something called DNA. So this is so we can put this on our database. It lets us know the genetic makeup of the shark, and it also allows us to carry on with some studies, and we can actually make family trees for these sharks. So because we have their DNA, we can work out if they've got mothers or fathers or brothers and sisters that we've caught before, and we can make a whole family tree. So kind of like if you look up your grandparents and everything like that. So all I do for that is we take a tiny little sample. Think of it as, you know, if you were clipping your nails or something like that. It's a tiny little sample. We take a little triangle with these scissors in here. So we just do quite a little snip. It doesn't hurt the shark. Like I said, it's like a little fingernail clipping. We put that, and then we put it in a vial, and we send that off for analysis. The next thing we do is, as Jill said, we do something, we put tags in it. So we put something called a pit tag in, which is the same thing as a kind of little fingerprint for this shark. As she said, a barcode for it, so we know which individual it is. So if we collect it again, we know where this shark was originally caught, and we know which individual it is. So we have a little inserter for these little tags. So it looks like this. And like I said, it's very, very quick. It just goes just in here. Doesn't hurt the shark. It's a very quick. It just goes pop underneath the skin, and it's all done. And it's exactly like, you know, if you're going to go to the doctor and maybe get a shot or something like that. Done very, very quickly, and it doesn't hurt the shark, but it enables us to scan them every time we catch a shark. So we put this in all the sharks we catch. We scan the shark. And as you can see, it's got a little pit tag number in it. So you can see the number just here, and that's the identification number for that shark. We're just going to pop it back in the little trough bit so it can swim around. But that is the basics for a juvenile nurse shark. There are additional things we take depending on the shark species. So I'm sure you guys have probably heard of some big sharks like tiger sharks and bull sharks. So for those, we've got a little bit more in depth. We take stuff like blood, we take stuff like muscle, and that allows us to really look at what that shark's been eating. So those 3 samples, as well as little DNA and isotope sample, it allows us to track what that shark's been eating over a year, which is pretty cool. So the blood's what it's eaten recently, the muscle's what it ate a couple of months ago, and then the little thin clip we take is what it's eaten over a past year, which is really cool because we can put that with all the tags we put on the sharks and work out where that shark's been going and what it's been eating in those different places.
Cool. All right, so what we're going to do now is see if the classrooms have some questions. So we'll go from each classroom. So when we've called your class, if you want to go ahead and unmute your microphone and ask a question, and then we'll go ahead and answer that, and then we'll move from classroom to classroom. So I'll let you get. All right, so first up, do we still have Miss Gonzalez's class? Do you guys have a question? You can either type it in the chat bar, or if you can get your audio to work, you can ask us. I don't know. Is Miss Gonzalez still on here? Yep. All right, yeah, if you want to go ahead and unmute your microphone.
Can you hear us?
You can, yeah.
All right, Elliot. Get up here, get up here. Can you?
Why do people kill sharks?
Yeah, so there's a few different reasons. One is for the things that the shark has on its body. That's probably the main reason. The fins, the meat, the teeth, they're animals, and people use animal products. Their fins are used for different products, specifically shark fin soup. The meat is eaten, the teeth and things are used for souvenirs. The oil from their liver is used to make different products like makeups, lipsticks, and lotions. So they are targeted and killed for the parts of their body to be used to make products. They're also killed for sport. They're considered a game animal. And because people are afraid. That's also a big reason. People are afraid of sharks. They don't like them, and they kill them because of that. They're also caught as bycatch, which means people are fishing for one thing and they catch something else. They get caught in nets and things like that. So those are kind of the main reasons that sharks are killed. But the problem is at that big number is too many. So their populations are struggling to keep up with that because sharks don't have lots and lots of babies like other fish do. They don't lay eggs the same way. Some of them might only lay 1 egg case or give birth to 1 baby. Right, so that's not a lot if populations are like
butterflies that lay hundreds of eggs.
Yeah, they don't have lots and lots of eggs, right? So they can't keep up with that. So those are kind of the main reasons that sharks are killed. And what we're trying to do is bring that number down so that more species don't become endangered or even extinct. Great question. Do you guys have one more?
Yes. Sadie, come here. Come here. Quickly. All right, Sadie, come on here, Sadie. That's your question. Ask. Oh, all right, Amira. Sorry, Amira. Go ahead.
Why
Okay. Can you get back to us or?
Yeah. We'll loop back around to you guys. So you get ready. We'll go. Do we still have Mr. Macey class with us?
Yes.
Hi.
You have to be ready.
Go to the,
Have to be ready.
stand up and say it.
I'm just going to have you mute your microphone. Hang on. I'll go ahead and mute it. Just give me a sec. And this class will get you. All right.
How do you handle big sharks like bull sharks or sharks like that?
That's a great question. So unlike the little small little bell we've got in here, big sharks are a bit too big for a big tub like this. What we actually do is we put them alongside the side of the boat. So we tie them at the tail to the back of the boat, and we have them at the front attached. So they're nice and long ways along the side of the boat. And we do the exact same workup just over the side of the boat. Great question.
I have one more.
One more question.
Do you have any of the sharks? I forget what they're called. I think it starts with an E that like live in the reefs, and when the tide goes in, they can go on land.
The epaulet shark.
Yeah.
Yeah. What's the question?
Do you have any of those sharks?
Oh no, we don't have them here. Tabitha has them in Australia though. Maybe she can talk about them.
They are in Northern Australia. I am going to be honest, I don't know a lot about them, but they are very cool. They do exactly as you said. So when the tide goes down, they actually use their pectoral fins to move across the reef, and they breathe the same way as the nurse shark does. So they're able to pump their gills, so then they can use a little bit of water and keep that oxygen flowing through them.
Yeah, they're amazing, right? A shark that can walk. So you might have seen one at an aquarium. A lot of times, if you've been lucky enough, a lot of aquariums have them. I wish we had them here. They're a really cool shark, but they're different cool sharks here. Great question. All right, do you guys want to do one more, and then we'll go to the next class?
Emily,
So
could you speak louder? I can say that. Move over. Move up more.
I have a question. Like, if you're catching like a big shark, like how do they not bite you? Like, don't they try to bite you?
Actually, the sharks are very calm. And when we catch them, we do it very quickly when we bring them to the side of the boat. And the sharks actually don't mind. They let us do it very quickly, and then we release them extremely quickly. So because we do it within 20 minutes, it means the sharks don't get stressed. There's no harm to the shark, and the shark swims off nice and strong. So actually, they're not that scary at all. They're very calm, especially if you wouldn't think it, the big tiger sharks, they just lay on the bottom ready for us to whack them up.
Question. All right, so we're going to go to Miss Kelly's class. She has a couple of questions for us.
Woo!
All right, we have Mimika who has a question for you.
Why does what you do help the sharks?
Well, there's a couple of different, just from the Sharks for Kids, I'll let these guys speak about some of the work the lab's doing, but education is really important because people think that sharks are monsters. They're scary, right? We see things on TV that tell us they're gonna swim up and bite us all the time, and you're in the oceans and they're looking for humans. We're not on the menu. They don't swim around looking for us. Think about it, millions of people go in the ocean every single day without any issue, right? So education is really important because guys have a bad reputation, right? So TV and the internet, and there's a lot of stuff out there that makes them seem really bad and really scary, but actually they're super important for healthy oceans. And so helping people understand that and learn the facts about sharks instead of a lot of the stuff that we might hear and see that's not true, that's really important, because the more people that know about sharks, know the truth about sharks, and maybe they'll want to help them.
Yeah, and we also study here shark movements. So as you've seen Jillian explain before, the tags that we use, that gives us a general idea of the movement of sharks. And in the Bahamas, we have something called a mangrove, which is a tree in the water, and a lot of these sharks use them as what we call a nursery. So it's an area that they're protected as they're growing. So the idea, what we try to do here is get an idea of where the nurseries are and the movements of the sharks, so we can create something we call a marine protected area. Now this marine protected area is an area where certain activities are not allowed, like fishing, general fishing, spot fishing, or like to bring boats in a certain area, so we can protect these mangroves, so as then we can protect the babies, allow them to grow, become adults, and then reproduce. And also, we're not just looking at Bimini, we're looking at outside of Bimini too, to extend the protected areas. So not only are they protected in Bimini, but when they leave Bimini as adults to go to other places.
Another one?
Eddie, come on over to the mic. This is Eddie.
Hi!
How do such big sharks get into such snow?
You should read the questions on your paper, sweetheart. Tracy, read that question, please.
What do you do when you see a shark?
Well, we usually get really excited. We're those people, if somebody yells shark at the beach, we find it in the water.
Here's a really detailed question. Let me help you read it. What do you, because do you get in the water with the sharks?
Yeah.
So what do you do when you see a shark?
Like, yeah.
Do you read it? Do you touch them?
Yeah, like do you
Or
touch
do you
them or do you like move around them?
Stay still and let
Or
them
stay
move
still.
around you.
Or stay still?
So I think we can all answer that, what we do when we get in the water. But the main thing is we do not touch the sharks if we see them in the water. They are amazing animals and they're amazing to see in the water. We get very excited and we love swimming with them. But we think it's really important that we don't touch the sharks. They are not pets like dogs or cats. They are wild animals like you would see a lion or a tiger. But they are so incredible. So they're so amazing to swim with. They're not scary at all, and it's really amazing to see them in their natural environment swimming around. And it's very, very beautiful to watch them. So we would say always watching is an amazing thing to do in the water. If you're in the water, don't be scared. Just enjoy it and let the sharks swim around and behave naturally and just enjoy the experience.
And we always say to remember just to respect the animal and give them that space that they need, because often sharks, like people, if they feel like they're being threatened, then they will respond to that threat. So that's where the confusion comes in sometimes. So as long as you give it that respect, you're going to have a really incredible experience with that animal.
You guys have one more question?
We would love one more question, right? I know. They all
It inspires us to research and learn more.
So this is Riley.
How fast are they? And like sometimes you have to like catch them when you're like putting on the tags.
So when we're putting on the tags, they're actually next to the boat. So we have them secured. They have a line around their tail, or they'd be in a tub if they're small. They'd be in a tub like this to be able to handle them safely. So we don't have to try and catch them moving. Imagine trying to, like if you were throwing darts and the dartboard was moving all around, all right, you'd miss. It would be, so we don't try and do that. Now, some researchers do use pole tags and they tag animals that are moving, like great whites. It takes a lot of skill, a lot of practice to make sure that tag is placed in the exact right spot. I've seen them do it on great whites. It's incredible. The boat driver, everything, they have a spotter plane. I mean, it's really this whole dance they've orchestrated and worked out to be able to get that tag in the right spot on the great white. Here, though, it's the animal is caught, making it much easier to get that tag on. So they can be very fast. Nurse shark, not one of the faster ones. Mako sharks are the fastest. They clocked anywhere from about 45 to 60 miles per hour. And so that's the fastest shark in the sea. So you would definitely have a tough time trying to tag one of them on the move. Awesome. Great questions. All right, so we're going to loop back to Ms. Gonzalez's class to see if you have a couple of questions to finish us off.
How far can sharks travel?
Oh. So it depends. Now this nurse shark may travel no more than 25 miles, 5 miles. All right, they tend to stay in kind of a home range, a much smaller home range. Imagine you just sort of staying in your school all the time, right? Now other sharks will go out into the city and then maybe towns further away, or you have things like white sharks that swim thousands of miles from Australia to South Africa, from the United States over to Mexico, to Hawaii. They travel incredibly large distances. They migrate. Whale sharks, tiger sharks, makos, blue sharks. These animals swim massive distances, long distances, and they'll do it in a seasonal pattern. It's pretty incredible to watch. It's almost like they have a road map or an ocean map they're following year after year. Other species, pretty happy in the place they find around a nice coral reef, and they don't need to go anywhere else. They've got food, they've got shelter, they're happy. So they don't need to travel to find a mate, to find food, to find a place to give birth. They can do all of that right in the area. But it depends on the shark, but some of them travel thousands and thousands of miles in a pretty short amount of time as well.
And some actually come back to the same place that they were born to give birth to their offspring. So the lemon sharks, for example, they're born here. Then as they get older, they'll go off and do their migrations, and then they'll return. We found that they return every 2 years to come back to the exact same mangrove that they were born in to give birth to their babies too. So that's pretty incredible, isn't it?
Kind of like our monarchs.
Or like a salmon. Like, like salmon
like
go
salmon.
back. Yeah. Great question. You guys have another one for us?
Kai, did you want another?
How big can sharks get?
Oh, okay. It depends on the species, but the biggest shark in the ocean is the whale shark. Have you heard of the whale shark?
Yeah.
It can get to around 17 meters long. The biggest one was recorded at 17 meters. That is really big.
It's about 55 to 50 feet. Yeah, that's okay. So scientists, we use meters and centimeters. That's the measurements. That's the standardized. So I know not everybody uses that in school. We do the inches and feet thing. So imagine a shark that's bigger than a school bus.
Wow.
Yeah, pretty awesome animal. All right. Well, thank you guys so much for joining us. Please, if you have more questions, you're interested, you can check out the Sharks for Kids page, www.sharksforkids.com. Activities, things to follow up. If you want to learn a little bit more about what these guys are working on, how to support it, if you're going to ever come to Bimini or you're interested in coming to Bimini, there's a lot of opportunities for the public, and that's www.biminisharklab.com. Make sure you check those out. There's lots of resources to learn more about these incredible animals, and hopefully we'll see you next time. So thank you so much for joining us.